In example number 3, we're asked to analyze the critical points, just the critical point at when x is equal to -1 of the function f of x is equal to 2x to the fourth plus 8x to the third plus 12x squared plus 8x plus 7. So let's go ahead and work on this. The derivative to get the critical, well, actually not even to get we're given a critical point, but we should get it as we work through this first derivative. So this will be 8x to the third plus 24x plus 24x squared plus 24x, there we go, plus 8. So when we plug in -1, we get -8 plus 24 minus 24 plus 8. So we get 0. So -1 is a critical point. Now let's take a look at the second derivative. Well, that's going to be 24x squared plus 48x plus 24. Now, if we take a look at the second derivative evaluated at the critical point, we get 24 times -1 squared plus 48 times -1 plus 24. So this gives me 24 plus a -48 plus 24, like that. And so what we end up getting is 0. Now, this tells us that we don't really know what's going on. This tells us our test is inconclusive. So what are we going to do about that? Well, what we can do is we can take a look at, we can either take a look at the original function, we can take a look at the derivative. Okay, if we knew what the original function looked like, we wouldn't have to go through these tests. So if we go ahead and we take a look at the derivative, okay, we can maybe see how this guy right here might behave around -1. So let's just do that. Let's take f prime of x, which is equal to 8x to the third plus 24x squared plus 24x plus 8. And I'm going to just factor this. I just want to see what's going on here. So if I factor this, I could pull out an 8, and I'm left with x to the third plus 3x squared plus 3x plus 1. Now this guy right here, I can work on factoring this by grouping. We'll try that. So what I'm going to do is I'm going to pair. Oh, actually, I'm going to pull out of the first two. I'm going to pull out what I can, which is x squared, and I'll be left with x plus 3. Now that's not going to get me where I want to go, right? Because I can't factor that out of here. So grouping that way doesn't look like it's going to work. What we could do is notice that this right here is using the binomial. This is x plus 1 cubed. If we cube this guy out, we get this guy right here. And so, again, if we plug in -1 in here, we clearly get 0 out. But now, what's happening around -1? Well, so here's -1. Now, at -1, okay, the multiplicity here is odd, because this guy's happening 3 times. And so since this guy's happening 3 times, we cross through -1. Now the question is, which way do we cross? So if we grab -2, we end up with negative 1 cubed, or negative 1, so we'd end up below. And if we grabbed 0, we'd end up with 1, or up above. So the derivative, okay, even though it has a 0 at negative 1, it's below over here and above over here. So what we've got is a negative slope changing to a positive slope. So negative slope changing to a positive slope, which means that at negative 1, we must be at a local minimum. So when you do the second derivative test, if it comes out to be inconclusive, well, you might have to dig a little bit further to see exactly what's going on.